Have you ever wondered why the continents fit together like a jigsaw puzzle? It's a question that has puzzled many for centuries. Imagine a time when all the continents we know today were once crammed together into a single massive landmass. This concept, known as continental drift, suggests that our continents have been moving and shifting around the Earth's surface for millions of years. This idea is not new, it has been around for centuries, but was only recently accepted by the scientific community. The concept of continental drift was first proposed in 1596 by Abraham Ortelius, a mapmaker. This is a name you may not have heard before, but Ortelius's keen observation and curiosity had a profound impact on our understanding of the world. As a seasoned mapmaker, he was intrigued by the jigsaw-like fit of the continents, particularly Africa and South America. This led him to suggest that perhaps these continents were once a single landmass but had drifted apart over time. It was a revolutionary idea, but in Ortelius's time, the notion was dismissed. The scientific community of the 16th century lacked the necessary tools and understanding to substantiate such a radical claim. There were no tectonic plates, no seismic readings, no deep-sea explorations to provide the hard evidence needed. Instead, the prevailing belief was that the continents were fixed, immovable structures, and the idea of them drifting apart was considered pure fantasy. Yet, Ortelius's theory was not forgotten. His vision of a dynamic, ever-changing Earth was so compelling, it lingered in the minds of geologists and mapmakers alike. The seed had been planted, and even though it took centuries to sprout, it eventually grew into the robust theory we know today. Ortelius's theory was ahead of its time, and it took centuries for it to be accepted. But in the grand scheme of things, it was the first step towards unraveling the complex and fascinating story of our planet's geological history. Fast forward to the 20th century, a meteorologist named Alfred Wegener reintroduced the theory of continental drift. A man of diverse interests and talents, Wegener was not content to simply follow the existing scientific consensus. He had a burning curiosity and a knack for seeing patterns where others didn't. This led him to revisit the idea of continental drift, a theory that had been floated around but never fully embraced by the scientific community. Wegener's approach to proving the theory was meticulous and exhaustive. He didn't just rely on one type of evidence, he collected a variety of data from different fields of study. Let's take a closer look at how he went about this. Firstly, he turned to paleontology. Wegener noticed that identical fossils were found on vastly separated landmasses. For instance, the fossil of a prehistoric fern called Glossopteris was found in South America, Africa, India, and Australia. How could this fern have spread across such vast oceans? To Wegener, the answer was simple. These continents were once connected. Next, Wegener examined geological formations. He observed that mountain ranges and rock types on different continents matched up perfectly when the continents were placed together like pieces of a jigsaw puzzle. The Appalachian Mountains in North America, for instance, seemed to continue as the Scottish Highlands across the Atlantic. Lastly, Wegener looked at the climate. He found evidence of glaciation or ice ages in places that are now quite warm, like South Africa and India. This suggested that these landmasses had once been near the poles, supporting the idea of drifting continents. However, the path of a pioneer is never easy. Despite his compelling evidence, Wegener's theory was met with skepticism and ridicule. His ideas were deemed outrageous and impossible. But as we'll see in the next segment, even the most radical ideas can become accepted truth when they're backed by solid evidence. The story of Alfred Wegener serves as a reminder that sometimes the most revolutionary ideas are the ones that challenge the status quo. The turning point came in the mid-20th century with the discovery of seafloor spreading. Seafloor spreading is an intriguing process that unravels at the bottom of the oceans. Picture this: magma from the Earth's mantle pushes its way up through fractures in the crust at the mid-ocean ridges. As it cools and solidifies, it forms new seafloor that gradually moves away from the ridge like a conveyor belt of creation. This movement of the seafloor carries the continents along for the ride, a concept known as continental drift. But how did we stumble upon this groundbreaking truth? The answer lies in the intricate study of magnetic patterns. As new seafloor forms, it locks in the Earth's magnetic field at the time of its creation. Scientists found alternating patterns of normal and reversed magnetism on either side of the mid-ocean ridges, mirroring each other like a zebra's stripes. This was the hard evidence needed to confirm that new seafloor was indeed being created and pushing the old seafloor aside. The acceptance of continental drift didn't happen overnight. It was a slow, gradual process, much like the drift itself. The evidence from seafloor spreading was compelling, but it was the development of the theory of plate tectonics that finally brought everything together. This theory proposed that the Earth's crust is broken up into large pieces, or plates, that float on the semi-fluid layer of the mantle. These plates move around, driven by the heat from the Earth's core, causing the continents to drift. The acceptance of the continental drift theory was a monumental shift in the world of geology, akin to the Copernican revolution in astronomy. It was a paradigm shift that required us to rethink our understanding of the Earth's surface. The Earth was no longer seen as a static entity, but a dynamic, evolving system. The continents were not fixed in place, but were slowly moving, reshaping the face of our planet over millions of years. This discovery forever changed our understanding of the Earth's surface. So, where does that leave us today? The legacy of the continental drift theory is profound and far-reaching. It's not just about the Earth's past, but also about its present and future. This theory has deeply influenced our understanding of geography, shaping how we perceive the layout of our planet. It has guided geologists in their study of Earth's crust, helping them predict where and why earthquakes and volcanic eruptions might occur. But perhaps most significantly, the continental drift theory has played a crucial role in our understanding of climate change. By understanding how continents have moved and changed over time, scientists can better understand past climatic patterns and predict future ones. This knowledge is invaluable in our ongoing battle against climate change. So, the contributions of the continental drift theory extend beyond the realm of geology. It has not only transformed our understanding of the Earth, but also our place within it. The theory of continental drift has shaped our view of the Earth, reminding us of our planet's dynamic and ever-changing nature.